This is the 2013 map. The unconformity can be spotted cutting across several different layers. It occurs at the base of rock unit G. So it occurs over here on the map, as well as over here, this area, where it cuts across F1. Besides the unconformity, there are a series of folds. Here we've got repetition of rock unit F on either side of rock unit B. The dip arrows are pointing away from each other, so we have an APT running north-south, and because we've got diverging dips, we've got an antiform in this area. To the east of F2, there's repetition of units. Unit F in the middle isn't repeated, but rock units B and E are repeated on either side. Even though the dip arrows are not symmetrical about this particular point, the layer that's not repeated, rock unit F, has to be the centre or the core of the fold, and this is where the APT would be. I've transferred most of the information from the map onto my scrap bit of paper. There are a few bits that I do need to add on because it's going to be helpful when we produce the cross section. First thing is I need to mark on the position of F1. I know it gets stopped by the unconformity, but I need to know where the position is. So what I'm going to do is transfer the information but use a different colour to signify that it's below the unconformity. Other things that I should also be aware of is that rock unit G, or the unconformity, is at different heights in different parts of the map. Over F1, this area here, it's at 250 metres high. So I'm going to mark that on my cross section scrap paper, and over here it's 375 metres high. So I'm going to mark that in here. One last thing is later on, when we start to construct the cross section, I'll transfer the position of the other fold onto the piece of paper. Right, so now we've marked on most of the information that we need. One thing that I need to do is work out the geological history, the order in which I'm going to do the cross section. Now, we know from completing other questions on the exam paper beforehand, and from looking at the spot heights, F2 displaces rock unit G and the unconformity. So that would suggest that F2 is the youngest feature on the map. So I'm going to mark that one in first. Once I've done that one, I'm going to mark in the unconformity and the layers above it, which is rock units G, C and D. Once I've put that one in, I'm going to mark in F1 because it isn't displaced by rock unit G, but it's older than the folded layers below. I'm going to put in the intrusion next, the Pluton and the associated Metamorphic Oriel, and then I'm going to mark on the folded layers after that. Okay, so we've been given a little bit of information by the examiners. They've told us the angle of F2. It's steeply dipping towards the west. We know from the map it cuts across every single layer, therefore going to extend this above the surface because we know that rock unit G and the unconformity must get stopped by it. So extended it over there. Now, just to give you a bit of a recap, the unconformity on this part of the map is at 375 metres, wherever over here it's at 250. So to the left of F2, it's at 250, to the right is at 375. We've used the scrap bit of paper at that point there. Now that should check out at 375. And at this portion of the cross section, that cuts here and there, that should be equivalent to 250 metres high. So I know both of those are horizontal. This section here is at 250. And there it goes up to F1 on straight across over there. So this is rock unit G here. It's also there. Now I've done G, I've done F2, I need to do C and D. Again, both of those are horizontal, so I can mark those on and we can go from there. Again, straight line, horizontal line across. Labelling up things as we go along. So I know this is rock unit G, I've got C, I've got D, and I've got C again up there. Okay, we'll finish this section off a little bit later. So we've done C and D. Now I need to do F1. If I go back to the map, I know it's directly underneath rock unit G. It's a straight line, so it's vertical on the cross section. Let's mark this in. You're going to use the blue line. It sits underneath the unconformity, so its position is there. Straight line, vertical line down, and it gets stopped by the unconformity. Making sure that I label up as soon as I've finished, so I'm not going to get myself confused. So we've done conformity F1, so I need to go A now. So this is the igneous body. So it occurs over here, and because it occurs on X, it's a curved igneous body, so it's going to be tilted towards Y at a steep angle, show that it's discordant, and it gets stopped by the unconformity, and I know that from a previous question, so I'm going to put in rock unit A. The dike that's on the map doesn't appear on the cross section, so I'm going to ignore it. Right, so what we need to do now is put the Oriel in, which I'm just going to leave for the moment, and then I'm going to do the folded layers. So folded layers now. We've got three areas, 1, 2 and 3. The easiest area to put in first is over here, then we'll complete this one, and then we'll do the section over there. I'm going to mark off the boundaries as close to the surface as I can to be as accurate as possible. I mark on the letters, so we've got rock unit F here, B there, and E underneath it. Double check, I've just got E in this section here, there's nothing else hiding underneath the unconformity. All of them differing 50 degrees towards X. So you put on your protractor, measure 50 degrees. Mark one boundary in at a time, get stopped by the unconformity. Degrees. So I've finished this section here. Okay, right, looking back at my scrap bit of paper, I know between F1 and F2 I'll have an antiform. B's in the centre at the surface, flanked by F on either side. I can see F continues underneath the unconformity here, so it's just those two layers of rocks. Let's mark these on first. First starts there, finishes here. This one's 50 best towards the west, and this one's 50 towards the east. label it all straight away. That's F. And B in the centre. It tells me down here that this is the base of rock unit B. So what I'm going to do is I'm going to measure this distance between the two, replicate it on this side of the fold and complete the antiform. This way, this thickness should be the equivalent to the one over here. And if I measure it, it is 1.7 centimetres. So I'm going to put a little dot up here, a little bit further up, 1.7 there. I'm going to do 1.7 here, and a little bit further down, join those 2 points up on this part of the fold. Extend this line higher, take it slowly so that you meet up the points overall. I've now completed the antiform in this area. I know because the angles are equal, I'm going to have a vertical fold axis. So I'm going to draw that one in. I'm going to label up as I go along, and there's my antiform there. Underneath rock unit B from this section is rock unit E, and that's just not exposed at the surface in this area. Right, so we're almost there. What we need to do now is transfer the information from this portion of the map. I know has got to have a synform. The fold axis should hit somewhere up here on the line of section, and I'll have two boundaries dipping towards the east, and I'll probably just about get this one in dipping towards the west. So what you need to do is extend this line up to predict where it would hit the base of the unconformity. Likewise over here. That's a guide, so you can use it, but you don't have to transfer the information across. And this one, look, goes over the end of the section. So I just need to put those two boundaries in. I'm going to mark this on here using different colour because I know it's the base. So this point there, this point here. So this is the start of rock unit F on here, and then it's the start of rock unit B on this side. I'm just going to mark on that I've got a synform in this particular area. They're going 50 that way, and this one's going 50 in that direction. So now let's transfer the information before we forget where it is. So there's the boundary between the E and B. This one's going to hit the base of the unconformity, it's there. So I've got E on this side, I've got B in the middle, and then I've got F here. And the return one is over on this side, so I've got B again there. This is going 50 that way, these two are going 50 in this direction. I'm going to start on the right hand side, I'm going to put this one in. I'm not going to extend it too far because I don't know how deep it's going to go down. So I'm just going to extend it a couple of centimetres. I'm going to do this one in now here on the equivalent boundary on the other side of the fold axis. So there's the angle that you need to mark in, and I can just keep taking that down until I've completed the fold, which is there. Now I just need to mark this boundary on over here for the EB boundary, 50 degrees. Now B, remember, should have the same thickness all the way around the fold. So if I measured this thickness here, I can measure the true thickness on that side and finish off this section. So that is slightly bigger on here than it is on the other side, it's 1.9. Let's measure that in two places, so I know I'm getting the right angle. That is, let me move it across here. And finish the fold off, so now I can put the fold axis in. It's a syn form. So I've labelled this as E, I've got B here, F there. All I need to do now is mark on the displacement of my faults. B is higher this side compared to this side, so this side has gone down, this side's moved up relative to each other, and E is lower on this side, higher on this side, so this side's gone up, this side's gone down. The last bit we've mentioned before but haven't marked in is the Metamorphic Oriel. So I know it's at this distance away from the intrusion there. Now it's going to mimic the same boundary tilt as the edge of the Pluton. Remember, it's formed by the heat being emitted from the intrusion, heating up the country rock. So ideally it's heated the same thickness of rock around the edge of it. So see, I've mimicked the edge of the Pluton, and I'm just going to put a few small M's on to show where the limit of the Metamorphic Oriel is. You're finished.